I want you to think about a coffee cup. All right, this is my coffee cup, and it just happens to be sitting on a table, like it often does next to my cat, who likes to climb up on the table. So there's my cat. So when we talk about motion or no motion, we can model this using something called a free body diagram. A free body diagram. So what is a free body diagram? Well, it is just a way to show the forces acting on any object at any time. So if we think about our free body diagram here with this cat and this mug, let's think about the mug itself. It is not moving, right? The force of gravity is acting on it. So gravity is acting on it. And the force of gravity is always pulling towards Earth's center. Now, that is not the only force acting on this mug because, as we all know, this mug is not in motion. So there must be a force balancing it. And so we call the force that's balancing it, as it's sitting on a surface, we call this a normal force. Normal just means perpendicular. So not like just normal, but like perpendicular. And so the normal force acts to push up from a surface in a perpendicular direction, so just kind of straight up from the surface. And so this is why this mug is balanced. And because it's balanced, there is no motion. But think about this, and hopefully this is not going to happen this morning. What if my cat decides, I'm going to push that mug? Well, that cat would be applying a force, and we call that force an applied force. So an applied force is a push or a pull on an object. And in this case, it is in the rightward direction. All right, but that obviously is not the only force acting on this mug, because as we all know, if we push an object, it's not going to go forever. Something is acting to resist that applied force. That force is the force of friction. And just about every surface on this planet, actually every surface on this planet, has at least some friction, some more than others. And so friction is a force that acts against one object sliding on another, so kind of opposes the applied force in this case. And so it's going to act in the opposite direction as that applied force. At first, if that cat only pushes with a small amount of applied force, there will still be no motion and the forces will be balanced. But if that cat applies enough force, it will overcome the friction and the mug will accelerate in the rightward direction, which would be bad news for me. So we can actually represent this in a much more simple way. And when we use a simple model to represent this, we call it a free body diagram. And so a free body diagram usually just starts with a simple square or a circle. And so this square can represent our mug. And so when we're talking about an object in motion or at rest and we want to show the forces, we can put a dot kind of at the center of the object and then draw the force arrows or vectors from there. And so the first force that we have acting on our mug is the force of gravity. So we'll represent that as an F sub g, the g for gravity. Force opposing that is the force normal or the normal force, F sub n. And those two forces are balanced. There is no motion up or down. However, if that cat applies a force, so we call that F sub A. We'll draw that force arrow in the direction that it's applied. And we'll draw the opposing frictional force in the opposite direction. If that arrow or that force that is applied is strong enough, it will be unbalanced and it will accelerate to the right. So that would be the free body diagram for a cat pushing a mug on a tabletop. What would it look like if that mug, oh no, went over the edge of the table? Well, we could draw another free diagram or free body diagram to show that. The only force then at that point acting on the object would be the force of gravity. And that would be an unbalanced force. The acceleration would be down toward the floor. And that would make me very, very sad. And so these are two examples of free body diagrams of the same object, just in two different situations. You can use free body diagrams to represent different forces acting on any object in any situation, and it can be helpful to show us balanced and unbalanced forces and the direction of acceleration.